Assalamualaikum and salam sejahtera semuanya. So kita masuk the last subtopic for this chapter 2. So 2.3 capacitors with dielectrics. Okay, so dielectrics ataupun nama lain dia adalah insulator is a non-conducting material. So you know what is insulator, right? So this dielectric is placed between plates of capacitor. So we have a capacitor here. So capacitor ni ada dua plate, metal plates. Usually it will be metal plates. And then dekat tengah-tengah ni, in between, we will insert a dielectric. So dielectric, okay, can be paper or glass, okay, any material that is non-conducting. Okay, so what happened, okay, when we put the dielectric in between the capacitor. Okay, so because it is an insulator, so untuk insulator, okay, dekat dalam insulator ni there is no free electrons available. Maksudnya dekat sini, okay, kalau kamu tengok dia ada positif, negatif, okay, all of these cancel each other. So dekat sini there is no charge actually. But if we put this, okay, dielectric, we put in between the capacitor. So kita ada capacitor, dekat sini negatif, dekat sini positif. So apa yang berlaku adalah, okay, initially dia hanya random sahaja. So the positive and negative charge ni is in random position. So when we put the dielectric in between the capacitor, what happen is, okay, all of this will align. So positive negative ni dia akan align, okay, to the electric field between the plates. So we know the electric field is from positive to negative, right? So that will be the electric field. So kalau kamu perasan dekat sini, all of the positive side will be facing towards the negative plate. So since dekat sini adalah negative plate kan, and all of the negative sides will be facing towards the positive plate. Dia tidak akan bergerak because it is insulator. So this charge will not travel. Dia hanya akan align sahaja. Okay, so that is what happened when we put the dielectric in between the capacitor. Okay, kesimpulannya dekat sini, okay, always ingat, if we put dielectric, okay, capacitance will increase. Macam mana kita tahu capacitance will increase? Okay, kita tengok case by case dekat sini. So here we have a capacitor connected to a battery. So kita tengok case yang pertama. The first case is, so lepas this capacitor sudah di-charge, this one has fully charged, and now we disconnected the battery. So kita hilangkan battery ni, so tiada sudah battery dekat sini. And then selepas disconnected the battery, we put the insulator here. Kita letak insulator. So maybe paper or glass or anything lah. Dan dia mesti fill in the gap. Okay, so what happened here? Because we already removed the battery. Kita sudah remove the battery. So maksudnya dekat sini, this charge, dia akan stuck dekat sini. So let's say we have positive charge here, negative charge here. Okay, dia akan stuck dekat plate dekat sini. Dia tidak akan dapat travel balik. Dia tidak akan dapat discharge because we don't have resistor and then we don't have the battery. So meaning that, okay, Q akan constant, charge akan constant. But if we put the dielectric, selepas kita letak dielectric kan tadi, so here what happened is, apabila kita letak, all of this akan cancel each other. Okay, this one, okay, here, because this one akan cancel, here akan cancel, okay, dia akan cancel. So meaning that dekat sini, okay, voltage, okay, across this capacitor will be reduced. Voltage akan reduce dekat sini. So when voltage reduce, so voltage will be reduced since Q adalah constant. Q constant kan? So this one constant. So when voltage dia reduce, what happen to capacitance? Dia akan increase. So voltage reduce, capacitance akan increase. This one is for the first case. Okay, first case ni adalah kita charge dulu capacitor. Lepas sudah habis charge, disconnect this battery. and then letak dielectric. Okay, so now second case. Okay, semasa capacitor ni masih lagi connected to the battery, still connected, and then we put the, okay, we insert the dielectric in between. Maksudnya dekat sini battery kita tidak disconnect, still sama. Okay, so apabila battery ni sama, still lagi connected, V akan constant because, okay, because battery ni dia punya, sebab dia keep giving the charge. Okay, because battery is keep giving the charge to the capacitor, so V dekat sini will be equal to V dekat capacitor. That's why dia akan constant. So since it will keep giving the charge to the capacitor, dia akan still keep giving the charge, meaning that Q will increase. Okay, dia punya charge akan keep on increasing. Selagi kita connect to the battery, selagi itulah charge tu akan bertambah. So according to this formula here, when Q increase, capacitance pun akan increase. So when Q increase, capacitance pun akan increase. So this one is for the case when the battery is still connected. Battery masih connected dan kita letak dielectric, paper or glass or any conducting material, tissue, anything. Okay, next one we have a constant we call as dielectric constant ataupun epsilon R here. Okay, so initially, so this capacitor is in vacuum. So maksudnya dekat sini tiada apa-apa lah diletakkan di dalam. Dekat sini hanya ada udara saja, which means it is in vacuum. So we know that, macam yang Miss cakap tadi, untuk kedua-dua case dekat sini, case semasa battery is connected and disconnected, okay, capacitor akan increase. Dua-dua case capacitor akan increase apabila dielectric diletakkan. So let's say we have we put a dielectric here. Kita letaklah dielectric. Maybe it's a paper. Okay, let's say it's a paper here. And we know that, okay, C will increase. So dekat sini adalah C naught. C naught ni adalah capacitance semasa tiada dielectric diletakkan. So apabila ada dielectric diletakkan, capacitance akan meningkat, which means now capacitance akan jadi ER, which is epsilon R, the dielectric constant, times with C naught, the initial capacitance. So maybe let's say the capacitance here is 50 microfarad here, and then paper ni dia ada dielectric constant dia. Dielectric constant dia epsilon ER, maybe 2. Dielectric constant doesn't have a unit. So meaning that apabila kita letak paper, capacitance akan meningkat menjadi 100 microfarad here. Okay, now we have another thing. Capacitance, dielectric constant, which is epsilon R here, doesn't have a unit, but dia punya formula adalah sama dengan epsilon divided by epsilon naught. So epsilon dekat sini adalah permittivity. Permittivity of the dielectric, and epsilon naught adalah permittivity of free space. Maksudnya dekat sini, meaning that here, E naught ni adalah semasa capacitor ni berada di condition vacuum, and then E here will be when the dielectric is inserted. Permittivity tidak sama dengan dielectric constant. So permittivity ni maksudnya adalah the ability of the material to store electric energy. So this one you don't really have to know exactly what it is. You just need to know what's the difference between epsilon R, epsilon and epsilon naught. So this one adalah constant value, which is at 5 exponent negative 12 coulomb square per Newton square per meter square. Per Newton per meter square. So ni adalah dia punya unit lah for the permittivity, but dielectric constant tiada unit. So kesimpulannya dekat sini, okay, kamu kena hafal formula yang kita akan gunakan dalam subtopic 2.3, which means okay, epsilon R is equal to epsilon divided by epsilon naught is equal to C here, capacitance apabila dielectric telah diletakkan. C naught adalah initial semasa in vacuum. So this one in vacuum, sama juga V naught dekat sini adalah from the battery. So here from the battery. So maksudnya dekat sini kalau the naught ni adalah initial condition semasa tiada lagi dielectric diletakkan. Okay, so depending on the information that we have, we can either use epsilon R is equal to E divided E naught, or epsilon R divided is equal to C over C naught, or these pairs. So itu adalah depends kepada soalan lah, nanti kita akan tengok dekat example. Or we use this one, C naught is equal to E naught. A here will be the area, and then area, since it is the area for the metal plate, right? So area dekat sini will be equal to, okay, area dekat sini selalunya dia akan bagilah, we don't have the formula, it's just that because it is a plate, so panjang dan lebar sahaja. And then D here will be the distance between the two plates, which is we have capacitance here, capacitor here. So distance between these two adalah value for D. So ni adalah untuk in vacuum, and this one adalah apabila dielectric diletakkan. So just ingat this formula lah dekat sini for this subtopic. Okay, so kita akan tengok example dekat next video. Alright, so that is all for 2.3. So I'll see you in the next video. Thank you.